Now see, in the last class we have done diode and we have done BJT, right? So in today's lecture we'll learn about the rectifier, okay, from the module 6. So basically the rectifier is the application of diode, okay. For that you should know what is rectifier. Do you know exactly what is rectifier or what is the function of rectifier? Tell me. Yes, rectifier is a device which convert AC supply to the DC supply. Now the question arises that it converts AC to DC, where we need to convert AC to. Can you tell me why there is a need of conversion, or where we are using rectifier to convert AC to DC supply? I'm telling you the practical example which you are using in day-to-day life. You are using that thing in daily, okay, on daily basis. That is charger. You are using either phone charger or laptop charger, right? So see, we are using socket supply at our home appliances is just like that. So this socket provides AC supply, and we are using phone, and phone is having battery. So wherever we are having the battery, that needs DC supply. So we are having AC supply and we need DC supply. So with the help of charger in the charger will have the rectifier that converts AC supply to the DC supply. Okay, just imagine if you AC is not be able to convert it into DC, then every time you need to change your battery of phone, then phone will be so accessible. No, no. Now you are using charger and you charge it. If you want to change the battery every time, then it wouldn't be possible. So that is possible only and only due to the presence of diode. And as you have studied, the diode is made up of semiconductor, and semiconductor is made up of sand. See, from the sand you are using, the human invention is like this. From the sand only they invented a very like electronic device that we are using, and without that we even can't imagine our life, right? Okay, now see the technical thing, that rectifier is divided into two category. One is the half wave rectifier and another one is the full wave rectifier, right? In the half wave rectifier only single diode is used. In the full wave rectifier, that is divided into further two category. One is the center tap rectifier and another one is the bridge type rectifier. Okay, in the center tap rectifier we are using two diodes, and in the bridge type rectifier we'll use four diode. Now see what is the function of half wave rectifier. As its name suggests, that it converts the half waveform. Half waveform means, like, suppose we are providing the AC supply. AC supply is like this only, right? And it's a half wave rectifier, so it converts half waveform into DC supply like this. Positive, and then means positive cycle is converted, negative would be 0, again positive cycle would be converted and negative would be 0. And in the center tap rectifier or the bridge type rectifier will have full wave rectifier. Full wave rectifier means it is converting AC supply, means positive supply, and the negative supply as well. Okay, so according to you, which we are using more frequently and which is having the maximum efficiency? Is for half wave rectifier or full wave rectifier? It's for full wave rectifier. In your phone, obviously you will use full wave rectifier now. You don't want half cycle would be converted into DC, right? Now the question arises, some students think that, ma'am, it's a AC only. No, it's not AC. Basically it's a kind of ripple. If I'll tell you in detail, like our DC supply is like this, right? But we are not getting the pure DC from the rectifier, we're getting a ripples like this. Okay, the DC and the little bit AC, DC and the little bit AC. So these are technically known as ripples, and we can remove these ripples further by using filters. That filters is not in your syllabus, so I'm not going into depth. Rectifier is in your syllabus, so I'm telling you this one. Okay, write it down, this one. Now see, after that we'll learn about the half wave rectifier construction and working principle. So they can ask you any one of the rectifier, they can ask you half wave or full wave. So see first the circuit diagram. As you know, it converts AC to DC, right? So we are providing AC supply, right? Then we'll use transformer. Okay, mainly we are using step down transformer to decrease the voltage, because generally AC voltage is higher and DC voltage which we want, that is lower. Okay, here we are using the diode, and here we are using the load. Load is just like load, what we can say, that you are using fan in your home, bulb in your home, that is the load. Okay, like as I told you, you are using phone, so phone is your load over here. Now see how it will work. As we provide the AC supply, means we are providing the sinusoidal supply, right? We are providing the sinusoidal supply, the positive cycle, and then we'll have negative cycle. This is the input voltage. Suppose we'll have Vs is the supply voltage, then we'll get output voltage. Okay, let's consider the first cycle first. First cycle is the positive cycle. So if we are providing positive cycle over here, then positive will be above and negative will be here. Similarly, positive will be here and negative will be here, right? And as you have studied about the diode, that this part is anode and this part is cathode, right? Now tell me, this diode D is in this case the forward bias or the reverse bias? Forward bias now. Okay, so anode is connected to the positive terminal, so it's a forward bias, and cathode is connected to the negative terminal. And in the forward bias, tell me, current will flow or not? So current will flow, will get the AC supply. Now for the negative cycle. Okay, now the cycle changes. If the cycle changes, then the sign will also change. Negative here, positive here. Similarly, negative here and positive here, right? So in this case, diode will work as a forward bias or a reverse bias? Reverse bias. And in the reverse bias, no current will flow. So in the negative cycle, we are not getting the output, that is 0. Again the cycle change, positive conduction, negative cycle no conduction. Understood? Now next is the full wave rectifier, and as I told you, in the full wave rectifier we have divided into two category. One is the center tap rectifier, another one is the bridge type rectifier. So in the center tap rectifier, suppose we are providing again the AC supply, again we'll use the transformer, we'll don't use directly the rectifier. Okay, and this is a step down transformer, that's why I'm making number of turns in the primary side more and number of turns in the secondary side is less. So that is showing that we are using this one as a step down transformer. Okay, here we are using, as I told you, two diodes like this. Okay, and center tapping means load is connected to the center of the winding, like windings should be equal. If suppose we are providing here we are getting 10 volt, okay, 10 number of turns, then 5 number of turns would be on the above side, 5 number of turns would be on the below side. Exactly we need to do as a center tapping. This one will represent it by D1 and this one we can represent it by D2. Okay, now see, in this case again we'll provide the AC supply, right? We are providing the AC supply. First we'll provide the positive cycle, then we'll provide the negative cycle. Supply voltage is Vs, So this one we can say that this one would be Vs maximum and this one would be minus Vs maximum, right? Now you tell me the output voltage, how it will works. If in the starting we are providing positive cycle, that means positive here and negative here, right? If positive is here, then that would be negative, and if negative is here, that would be positive. Now this is anode and this is cathode, right? So now here anode is connected to the positive terminal and cathode is connected to the negative terminal. Now you tell me, this diode D1 is work as a forward bias or a reverse bias? So basically in this D1 and D2 both will work. Okay, D1 and D2 both will work. In the positive cycle, D1 is conducting, so current will flow across the load, and in the D2 cycle current will flow across the load through the D2. So in the half wave rectifier only there is a conduction in one cycle, but in full wave rectifier there is a conduction of in due to the double diode. After this we'll have bridge type rectifier, right? In the bridge type rectifier, have you listened about the Wheatstone bridge? So in the Wheatstone bridge we'll make a kind of structure like this, and in this we'll have 4 diode. Okay, so in this case now you are going to tell me that which diode is working at which cycle. Okay, these are the 4 diode and in between load is connected. This is D1, D2, D3, D4. Okay, so in this case in the positive cycle when D3 and D4 will be act as a forward bias, and in the negative cycle D1 and D2 will act as a forward bias. Okay, so in the paper you will get the simple question that what is rectifier, because in this they'll give you the numerical, they don't give you the numerical, generally give you the theory part only. Or they can ask you what are the different types of rectifier, what is the application of diode, and they can ask you explain the construction and working principle of rectifier. Okay, clear? So all the diagram and the procedure which I told you, I provide all these things in your notes. Okay, now rectifier is also completed. Now after that we'll learn about the zener diode. Okay, now have you listened about the zener diode? Tell me then what is zener diode and why we are using. See, the very first thing, zener diode will work only in the case of reverse bias. Okay, if it works in the case of reverse bias, that doesn't mean it allows the current in reverse bias. Okay, that is not there, it works in reverse bias only. First thing. Another thing, it will use as a voltage regulator. Voltage regulator means it will use to maintain the output voltage must be constant. Like suppose we are using at our home AC, air conditioner. AC means air conditioner. So in that you will get attached voltage stabilizer, right? Have you seen that? So why we are getting the voltage stabilizer attached from that? The reason for that, that is that if suppose the input voltage is vary from 200, then AC will not be able to bear this 200 volt. It is very less voltage, but due to the voltage stabilizer it will provide the constant voltage, that is 220 volt to AC, so that it will not affect or it will not harm the air conditioner, right? So basically work of voltage stabilizer, whether the input voltage changes, output voltage must be constant. So Similar over here, that output voltage must be constant and it will work as a voltage regulator. Zener diode is basically a highly doped semiconductor. Okay, and it is specifically designed in function to the function in the reverse direction, and the voltage across zener diode is denoted by Vz. Okay, so sometime they can ask you the zener characteristics. I remember I told you the diode characteristic. So this is for the forward bias, and if there is a zener, then that is known as zener breakdown. If we are using the zener diode, then in that case breakdown will occur so early, and that is known as avalanche breakdown. That is the normal diode function. Okay, so zener diode in this will have a particular fixed circuit, like this is suppose the supply, this is resistance, this is zener diode, and this is the load resistance. This is load resistance is denoted by RL, series resistance is denoted by RS, this is VS, voltage across zener would be Z, voltage across load would be VL. It is always connected in parallel. Okay, zener diode is always connected in parallel to the load to make it reverse bias. See how, like suppose the current is flowing over here. Okay, so now tell me, if I connect the zener diode like this position, will the current flow in zener diode? No, it will work as a reverse bias or not? So in the reverse bias current will flow. So maximum all the current will move through the load resistance. So zener diode is connected parallel to the load to make it reverse bias. Once the zener diode exceeds the knee voltage, the voltage across load becomes constant. Okay, I'll write down this statement. Once the zener diode exceeds. After this we'll learn about the MOSFET, then I'll teach you the op-amp. Okay, MOSFET and op-amp I'm not going so detailed right now, because these are those topics which there are less chances to come in exam. Okay, but still I'm teaching you, and if your teacher teaches you these topics, then let me know, I'll teach you accordingly, because maybe they'll give it in a paper because it's in syllabus, so they can give it, right? So now the question is, what is MOSFET? MOSFET means that is metal oxide semiconductor field effect transistor. Okay, metal oxide field effect transistor, that is known as MOSFET. So from this what you can see, that it is a kind of transistor only, right? It is the kind of transistor only. In the MOSFET basically it is a will have four things, like in, remember in transistor we have studied the three things. One is emitter, another one is base, another one is collector. Similarly in the MOSFET will have four things. One is the source, another one is the gate, another one is the drain, and another one is the body. Okay, so in the MOSFET it is a unipolar like, remember I told you that transistor is the bipolar. Why bipolar? Because in this there is a movement of electrons and holes both, but MOSFET is the unipolar device. Unipolar means either in this electrons will move or in this holes will move. Got it? So what is the categorization of MOSFET? MOSFET is further divided into two categories. One is the enhancement mode. If they'll give you the question of MOSFET, then that would be easy, and all these things you need to write it down. One is the enhancement mode and another one is the depletion. Okay. Enhancement mode is further categorized into two categories. One is the P channel and another one is the N channel. Similarly, here also P channel and N channel. Now see what is the difference between the enhancement mode and depletion mode. When in the depletion mode, when there is no voltage across gate terminal. I'll write it down because you will get to know later on what is this. When there is no voltage across the gate terminal, the channel shows maximum conductance. Okay, when the voltage across the gate terminal is either positive or negative, the channel conductivity decreases. So this is depletion mode. And in this case, when there is, wait, let me tell you the diagram first, then only you will get to know my statement. Now, right now, I am telling you the N channel MOSFET. Okay, in the N channel MOSFET, we'll take the P type body. Okay, and we have done the doping of N positive. Can we do the doping of N positive in the P type body? Yes or no? Like in the transistor or diode, we have taken P and N like this, but in this we have taken complete the P type body and N type body is positive, like that we have done doping of N type. Got it up to here? And in between we'll have a layer of silicon dioxide. Why we are having the layer of silicon dioxide? So this layer is used as a insulating material. Okay, this layer is used as a insulating material. Why we are using this layer as a insulating material? Because we want that there is a N channel, that means negative electrons are there, and there is a N channel, negative electrons are there, and there is a P channel, means holes are there. So we don't want that there should be conduction from this N to another N through the P type. Okay, that's why we have done insulation layer, so that electrons from this N channel won't be able to transfer to another N channel. Got this point? Okay, now here source terminal is connected and here drain terminal is connected. Okay, and through the insulating material gate is connected. Okay, now see, this is P type. P type is the majority carriers. Here source is connected to the negative terminal and gate is connected to the positive terminal. Okay, so the voltage which is connected across G to S, that is known as VGS. Similarly, we'll connect the source and the drain. Here source is again connected to the negative terminal and drain is connected to the positive terminal. Here the voltage is VDS, right? Correct. Now the thing is, we'll have P type in the majority carriers and then electrons are there as a minority carriers. So whatever the minority carriers are there, they'll come over here. Why? Because here we are giving the positive charge, and positive charge attract the negative thing. So all the minority carriers will move towards this layer. Yes or no? And they'll not be able to move further because there is a layer of insulation, so electrons won't be able to go further. Now what happens if there is a N, means here also the electrons, here also the electrons. So basically the junction between this area and this area diminish. Okay, see why there is junction. If there is a p type and n type, two different type, then only junction will form now. If all are of n type, then there will be no junction, right or not? So there will be no junction, so this will be no junction, so that junction, there is a path that will form like this. Okay, so electrons will travel from here to here, and see the movement of electrons. Here the electrons are there. Now that junction removes, then electrons will move like this, and then electrons will move like this. Okay, now see, if we decrease the value of VGS, then this channel, this is known as channel, right? And it is of electron channel, that's why we called it as a n channel. Understood? That's why we called it as a n channel. Now see, if we increase the value of VGS, then more and more electrons will be attracted over here. And if more and more electrons will be attracted over here, the channel width increases or decreases? Increases, right? Because if we increase the if we decrease the value of VGS, then less number of electrons will be there, and then in that case channel width decreases, right? And if channel width decreases, then less electrons will be able to flow, and then less drain current will be there. Now take it vice versa. If we'll increase the value of VGS, then more and more number of electrons will be attracted over here, and if more and more number of electrons are attracted, then they'll form a channel, right? Then channel width increases, and if width increases, then more and more electrons will be able to pass, and then in that case drain current increases. So you can see that if we decrease the value of VGS, then drain current decreases. If we increase the value of VGS, then drain current increases. So through the VGS we are changing the value of drain current. Understood? Right. Okay, symbol of transistor, as you have studied, it is like this, right? Similarly we'll have symbol of MOSFET. Like as you can see, it is having mainly three terminal. The above one is the drain, this one is the gate through which we are controlling, this one is the source, and this is current is moving entering like inside, then that would be N channel. If current is moving outside, then that would be P channel, and this complete is body, right? I'm drawing for the P channel as well. This is drain, this is gate, and this is source. Okay, this is for P channel. Write it down. Now last topic of your 5, that is this one, zener diode, BJT, MOSFET application, rectifier, voltage regulator. Last topic is operational amplifier, that is op-amp. Okay, in short we called it as op-amp. It is mainly a electronic device only. Amplifier. So in this case we'll have op-amp. This is positive, this is negative. Here is the output, that is plus VC. The supply will provide it like this, plus VC, then we'll have minus V. Positive terminal is denoted by non-inverting input, okay, and negative terminal is denoted by inverting input. So basically what is the function of op-amp? It amplifies the voltage. Like suppose If you provide the voltage at this particular amplitude, then in the output you are getting the amplified voltage with all the things is same. Okay, so now there are lots and lots of op amps. First draw this symbol. One is the inverting op amp and another one is the non inverting op amp. Okay, if, like as I told you, the op amp symbol, right, if there is a voltage which is connected over the negative terminal, like suppose I have op amp like this, positive is grounded, negative is here, and there is a feedback resistance. Feedback resistance is always denoted by RF. Input resistance is denoted by V1. This one is V in the supply voltage and the output voltage is V out. That you need to remember because I am not telling much in deep. So if voltage is connected to the negative terminal, that would be the inverting amplifier. Okay. And there is a formula, fixed formula for output voltage for inverting amplifier, that is minus RF by R1 multiplied by. Next we'll have non-inverting op amp. Suppose we'll have op amp like this, positive, negative. Here feedback is always connected with the negative terminal. Resistance RF is there, R1 grounded. But here if we are providing voltage to the positive terminal, then in that case that would be the non-inverting, means voltage is connected to negative, non-inverting means voltage is connected to positive. Okay, so V naught is how much is, that is in plus RF by R1. Actually there are many kind of op amps, but we can learn these. Okay, voltage is connected to negative terminal, inverting. Voltage is connected to positive terminal, non-inverting. So if we'll see the output, inverting means our output will be inverted. We are providing positive supply, but in the output we are getting negative first and then positive. Non-inverting means if we are providing positive and negative first, then we'll get the same phase, but output is amplified.